Uh, there we go.
All right. Hi, everybody. I'm Andy. I've been with the club on and off for 33 years. Probably started just a couple years after Herman. Um, I started in film and astrophotography and film and visual both at the time. And then my kids started getting older and I took a break. Um, and then my kids got out of the house, so I came back. So, and I apologize for not being at the club meetings the past year. Work has been kind of crazy, so but it's starting to settle down now. Yeah, so I got back in it in 2018. Just started with a star tracker and a DSLR and a camera, a couple different camera lenses and slowly built up to the point now where I have two imaging rigs that I run during the clear nights, like back in October. Um, uh, so yeah, and I run all those. I'll do a presentation later in either for the club or later on in the year about that whole setup and how it works. So my bigger scope is a 5-inch refractor and it sits out there semi-permanently underneath some significant covers and heaters. So, all right. So with that, let me start sharing. You now got to give me permission, Mark. All right. Thank you. And we will share which screen? This one. All right. So hopefully you see this is probably my favorite picture I've ever done, even though I've done lots since, but that's the Crescent Nebula. And but tonight we're going to go through PixInsight, and I don't really, this is a high level view. Um, I just want to give you an idea of how it works, why it is so complex, but it doesn't have to be. Um, Really, I learned kind of like Greg inferred in the introductions with hours upon hours of YouTube videos and subscribing to some good channels, which I'll send out in an email of what I think the best channels are, including PixInsight, which are doing their own, how-to videos. But PixInsight really has, I think, really four main things to get used to. The one is the left-hand side here, where you can see different histories, what scripts, file, explorer, process. This is the one that you look at most of the time. It's what is happening when you're processing. The other basic thing are these tabs at the bottom. They're called workspaces. And I tried to be pretty organized with them. So I have a stacking workspace I'll talk about the icons later, although I don't use the stacking workspace all that much anymore. Linear processing, which means the unstretched images in another workspace. And then in the final, really the way it is, my final workspace is the stretched. And they all have their own processes, and all these icons really are processes. Let's see. And after I get through the basics, feel free to interrupt, okay, and ask questions.
I want to interrupt right now.
Go ahead.
Is PixInsight something that you have to buy a license to use, or is
Yeah, that's a really great. I should have started with that. So, but I wanted to talk about some other parts of it after as well. Yeah, but PixInsight is a one-time purchase.
okay?
And I used to do things in Photoshop, but I really got tired of the annual license. So, I stopped using Photoshop 3 years ago. And basically my purchase of PixInsight plus the paid plugins I have, which I don't think I need any more paid plugins, is now I don't have to buy anything anymore.
Okay, thank you.
All right, so the other kind, and this is where people get really distressed when they see PixInsight for the first time, because when I click on this process icon, it's overwhelming. You're like, what the heck do I do with this? Right? And you think you just don't know where to start. So that's why I think YouTube is such a vital resource. And basically, I ignore 85% of those processes. I don't even care. So the other thing, which is really valuable, is the scripts. So PixInsight comes with, you know, a pretty good, significant amount of scripts when you get it. But you can also add scripts that other people write. And there's some really good ones. So if I go to resources, I can show you a little bit about, you know, so here's your basic PixInsight stuff. But then you can get, these are RC Astros, the paid ones, but all the other ones are just free that people have written, including one you may have heard of that's good for any processing, Graxpert. Has anyone heard of that? Yeah, so that's a gradient removal program, and it is wonderful. So if you're not using it, you should, because you can use it in standalone. You can use it in PixInsight. So I'll even show you how that works as we go on. And then of course we have you know, all these are kind of the most used icons, and I probably use the auto stretch a lot, and maybe sometimes a preview that's inside. So that's kind of the overview of what's in PixInsight, but the real beast of it all is this. And you know, oh, flux calibration, right? Because I own a DeLorean, you know, that goes to the future or something. Yeah, I have no idea what that is, but I also don't care, because I found a routine of, and it to me, I can do my if I'm starting with an RGB picture, I can be done in 30 minutes. That's because I've refined it over time. All right, so any other questions about the workspaces, the processing, or whatever else before we go in? And I'll kind of give you a demo of what we got.
Yeah, hey, Tom, here's another question from a guy who doesn't do a lot of this. When you bring a image into PixInsight to begin processing, what file type is that?
It doesn't matter really. It'll take FITS files, it'll take JPEGs, you know, it'll take anything any normal program would do.
Okay.
But then you're better off converting it to a PixInsight file format.
Okay.
It's a good question. Any other questions before I get started?
Yeah, Andy, real quick, are you going to talk just about a color image, or are you going to talk about
Yeah, I'm gonna
filters and stacking?
Yeah, I'll do a little bit of that because let me talk to you about the one thing in PixInsight. It's called weighted batch processing. So it's basically it's the deep sky stacker plus a lot of calibration options that you don't get there. But you know, some people who use PixInsight don't even use this. They just like to do it on their own. But basically, I'm like Queeve. I'm pretty lazy. So for me to so let me tell you about this. My computer is 10 years old. It's Windows 10 and I don't even think it started out as Windows 10. And when I do this weighted batch processing, it basically will go all night. But you know, then again, I'm stacking you know, maybe 300 subframes when I do it. Right. So, you know, you can, I'm not going to go through all this tonight, but you can take an entire directory of files and it will arrange them all, you know, into whether they be flats in there, darks, bias. It has calibration options, which you can choose how to calibrate it, whether you want darks or darks and flats. Output pedestals, which I won't go through explaining. But this one, this cosmetic correction, I think is really helpful because it kind of does some real basic color correcting of things that are out of whack. And then if you're stacking RGB files, you would use this color. I forget what CFA stands for. Color. I don't know if anyone else.
Filter array, if I remember.
Yeah. Color filter array. Yeah.
Hey, Randy.
Yeah.
I understand. I've been going through stuff and I understand taking darks. I don't understand flats.
Yeah,
How do you take
that's a whole nother subject. Maybe we could. I think that would, Mark. I think that would be a great subject for another night.
Yeah, what we could do is talk about calibration frames.
Yeah, absolutely.
Okay.
Yeah, let me give you a 1 minute overview. So, flats will do two things. It'll remove maybe dust that's on the sensor. Your dust that gets on the lens on the front of your, like a reflector, or even if it's on the back of a Newtonian, it doesn't come into play. Usually it's just the sensor. The other thing it deals with is the vignetting you might have, right? So in the corners, you know, if you look at well, maybe I can find a good one. Let me pull up a flat frame so you can see it.
So flat frame compensates for the optical path
Right.
imperfections, whether it's dust bunnies or curvature of the refractor lens or the Newtonian lens, but it divides that stuff out. The dark frames subtract data. Flat frames divide that data out.
Yeah, Mark can tell you the details a lot more than I can.
So how do you take them?
You take them just like a dark frame, except you put like let's say a t-shirt over the front of your telescope, and then you experiment about the length of time, but you take it through each filter, and then it depends on the exposure. That one's not a good one, but the one he had a little bit before that, you have to find the range so that one takes away a lot of the vignetting. So somewhere in between those two.
Yeah, so this is just screen stretched. That's not really. This is what it looks like, but you can see in the corner. I hope you can see in the corners the darker parts, right? And by using the flat frames, it'll add light to there to make up for, you know, to match what's in the middle, basically. That's a layman's term.
So the other thing about flat frames is you have to take the flat frames just like you took the light frames, which means one of two things. Either you do it at the telescope the night you're doing your imaging, or what I've done is I've got my rig all on one assembly, so I can do it the next day without inside the house without changing anything. That's with a cool camera. With a non-cool camera, you've got to do it at the time you're taking the light frames.
Yeah.
How do you get such clean frames? Didn't notice any dust there.
Yeah, you're right. That's because I never ever take my imaging train apart.
There you go.
So there's no chance of dust getting in there. The only time I take it apart is if I'm buying a new filter or something. So yeah. So even when I take if I take my telescope apart, that the field flattener all the way back to the filter wheel and so on. That never comes apart.
But it doesn't matter if you have dust under. If you take flats, the dust
That's right.
will be divided out of the data.
But I don't like having to deal with it at all. So
No.
I started
No.
clean and I keep it clean.
I agree.
Yeah. All right. So yeah, let's get into a little bit of, I'll go through you with my steps of processing. So if I'm shooting, I have two, I shoot both in mono, and my small rig I shoot in 1-shot color. So, but I'm going to go through M106 tonight, and that was done with RGB. I didn't, for this process, I ended up not even using the luminance. And the reason is, and this is, I think, is really important, is here, I'm going to bring up the color, totally unedited image, right? So what makes this a good picture is not so much the stacking and whatnot, it's the amount of data I've collected. So this represents like probably, I should go back and look, but it's like 10 to 15 hours. I've collected this over multiple nights. And so the data is really good to start with. You have noise, but we can deal with that. So the more data you collect, the cleaner the image is going to be, the easier the processing is going to be, right? I think Walter, and maybe, I got to look at the list. I know there's, John, right? You guys know that, and maybe others of you do as well. All right, so basically, when it comes to this, I combine the channels. I don't have to do a crop because the weighted batch pre-processing does that automatically. I don't even use these anymore because I use a paid plugin to do the get the gradient out. PixInsight has a really nice color correction process. And I have these icons here, and I'll just show you for an example. This icon is created with the settings for my setup, right? So they're narrowband filters, 3 nanometer. I have the right wavelengths in there. Then for the RGB, they again, I have a beta R, G, and B. And so once you save these icons onto the desktop, which all you have to do is with this little triangle at the bottom is drag it there, and then you can rename it to whatever you want. And it will always remember your settings. So that's kind of I think, a really powerful part of PixInsight. So then now we get to the three of the paid settings, which paid plugins, excuse me, which ended up, I don't, Walter, how much did these cost when you buy all 3 together? Do you remember?
This is Brian.
I think
This is Brian. It was 79, I think, for me when I bought all 3.
Okay.
It
I
wasn't
think
bad
if
deal at all.
you bought one, you get is it 15% off the rest?
Yeah, he had a package deal at one time. RCS.
The first one, I think, is like $99, and then it's $49 for the other 2.
Yeah, I think that's what I paid.
Yeah, that's the same as what I had too. It was, there wasn't a package deal that I saw.
Yeah.
Yeah, this is like 2 years ago when I got it.
Right.
First starting.
Yeah. When they were just newly released, right?
Mm-hmm.
Yeah. Well, let me tell you, it's $180. It's probably the best $180 I spent in this hobby.
Well spent. That's right.
Because the blur exterminator, it takes your stars that are oblong, makes them perfectly round. So if you have problems in the corners of your picture, like I do sometimes with my one-shot color rig. It'll just fix those, but it also enhances the deep sky object. And naturally too, it's all done through machine learning and whatnot. So it's AI, based through machine learning. The noise exterminator, I don't have to deal with any of the noise, it just does it. And the star exterminator, so if you're familiar with processing, one of the easiest way to process pictures is either to mask the stars or to pull the stars out, process your image, then put the stars back in at the end, which is what I do. So those three plugins probably saved me about an hour per picture, and the quality comes out better than I could do it on my own. So, Russell Croman, he's done a marvelous job with it. Yeah, so really, so how many steps? 1, 2, 3, 4, 5, 6 in a linear state. All right, so here, what I have here is, this is not what it really looks like. This is what it really looks like. But this screen transfer function is just how it might look like when you're done. Right, so this is just a linear state object. All right, so the first thing I do is I pull out the gradient, and we can do that. I'll show you. So that's a new script, probably only a month old, that it's been brought into PixInsight, and it's just Graxpert, which I said before can work standalone. And I've used it that way, so I would encourage you to check it out, even if you're not using PixInsight. I'll try and find the links for that and send it out in an email. So it's pretty quick too. So if I usually set it around 0.49 or whatever, but you could play around with the smoothing on it. You're subtracting out, and it's relatively fast. It's like 30 seconds or so for me. A new computer would probably do it in 5 seconds. So it takes a while to start it up, because it's not part of PixInsight. It's executing a program that's outside of PixInsight. So really, I think gradients is probably, for me, has always been the hardest thing to deal with. And having another tool that does it automatically, this one too is AI based, I've found is just worth its weight. Well, not in gold, but maybe something. So what I really like, so here's the gradients that are in my image, right? And it's a pretty clean image, right? You don't have a lot of, the flats have took care of a lot of the vignetting. But there's a lot of weird colors going on because there's a lot more greens and whatnot. So that was all pulled out of it. So it's probably hard for you to see, but it's a lot smoother background. I could probably demonstrate some really bad ones, and I probably should. If we have time at the end, I don't want to cut into Greg's time. So that's the gradient portion. Then we do some color correction with the photometric color calibration. So we all that's one of the always things and steps that we're after, and it doesn't matter what program you're in. You want to get this colors to be as authentic as you can, and that this photometric color calibration process, it'll go through and pull a catalog, based on a catalog. It'll know what to check against because of your image properties. I probably should show you that. So process fits header. So if you're shooting in fits, you always have this kind of information, right? Right. So here's the coordinates of where I was shooting. you know, the lat, the date I took it, the lat and long. You know, here's the long, the lat and the long. And any other kind of data you put in there. So it knows what it's color calibrating against, but you got to have a catalog to check it against, right? So it's part of the deep sky imaging, you know, is the, and all you guys with the C Star, and guys and girls, with the C Star 50, you know, it's all doing this plate solving, and all that stuff is probably built in if you're doing it in the FITS format. Yeah, and then I do the blur exterminator, which in this you can't really tell too much in this image. Let's do this. So we'll go here, and put it over top. So if you, I don't know, can you see this little like halo on the one side? Is that viewable to you?
Yeah.
Yeah, so let's set it to that one. Now I'll click on it and you'll see it's reduced the star size a little bit, and that's okay in my book, because when you're imaging, you end up getting a star bigger than it really should be, because either through dithering or just your gears moving, the star just becomes bigger than it should be. So you can see how it's corrected that star. Oh, I'm doing it the wrong way. Bigger, halo, no halo, and smaller star.
Andy, are you using the version 4?
Yeah. Yeah.
Yeah, I found it makes a lot of difference too.
It does. It has done a really nice job. And
Hey,
now,
Andy. Oh, I'm
yeah,
sorry.
Go ahead.
At each step after blur exterminator and all that, you're supposed to save the image again, right? From that?
You can.
Because sometimes I've lost that Gaia stuff. The some of the properties I've lost.
You shouldn't lose that through blur exterminator. If you do a dynamic crop, it'll lose them.
Yeah.
Okay.
What else would make it lose? Or if you did a rotate, well, watch if I do a rotate. Geometry.
If you use clone stamp or something like that, it'll mess it up too.
Oh, this one doesn't even have it in there.
There is a script though under what's it called, image corrections.
Yes.
So you can run your plate solving.
Yeah. Image analysis. Yeah.
Okay.
Image solver. Yeah.
That will put the properties back in, but you have to tell it usually what you were shooting.
Right.
Okay.
Right. So watch. So this is my blue channel with my blue filter. You can see it. Look how bad this is. You know, from a gradient point. Actually, that might be a fun thing to do, because I really did want to do that. Let's just take the gradient out of this. It'll be a lot faster because it's run once. So I'm thinking of Jim, of some of your pictures where you struggle with the magentas. I think if you ran Graxpert, it would take care of a lot of that. Yeah, so see, this is what it extracted out, and look at what it's left with. I mean, it looks really nice. All right, so what was I saying? So yeah, if I do the image rotate, geometry rotate. Oh, what the heck? I must not have had the image properties in there. Okay, you'll just have to take my word for it. I'll show you on the final version. Okay. All right, so that is pretty much the linear processing. 1, 2, 3, 4, 5, 6. And 4 of the 6 are scripts. I don't have to think. Right. And channel combination is pretty simple too. All right, here's the R. I drag it into the R, G, B, and that's it. And you see how ugly it's going to look, right? but that is because, so if I do this little magic here, and the Grexpert would correct all that as well. So, the linear phase is quite easy. It's actually the non-linear where we've got a stretch picture, where that's where it gets a little tricky. So, any questions on linear processing?
Yeah, I have a question. To me, I'm looking at these two images, both of them, and there seems to be a halo around the galaxy.
A little bit, yeah.
Is that understood?
Yeah, that's I think that's a little bit of the Grexpert. So I might need to like back off a little bit, but I usually don't care because I kind of take care of the background a little bit anyway, which I'll show you in a little bit.
Okay,
But yeah, that's a
thanks.
good catch on your part, though. Oh, also, I think this other galaxy is pretty cool, by the way. Isn't that pretty amazing that we can do that with our telescopes? Any other questions on linear?
Andy, you've mentioned the difference between linear and nonlinear images. Could you describe what you mean by that?
Yeah, so when it's in this linear state, you haven't stretched it, right? It's still dark to us, right? You can't see anything. I mean, this screen stretch, this auto stretch function, it's not really stretching it. It's just giving you what it would look like if you did stretch it. So well, actually, it's very similar to the way that I do it. In Photoshop, you're doing it with histogram, right? You start using histogram to stretch it. Or you could use curves to stretch it, right? And to get it to be visible like this. Right. All right, let's go forward because I want to make sure Greg has plenty of time to do his presentation. All right. So
do you why don't you remove the stars in the linear state?
That's a great question. And a lot of people do it. I just have found it doesn't work as well for me with my processes. I am not saying that my process is the best process by any stretch of the imagination, but I am content with my process. But you're right, a lot of people do that. But then you have to stretch both sets. You have to stretch your deep sky object, and then you got to stretch the stars. And I like them to be equal on their own. That's probably just, I don't know what you call it. All right, so here we are. This is the pre-stretch version. Oh no, this is stretched. So what I do to stretch an object is really, I'll show you here. It's a very simple process for me because I don't use the complex yet. I don't use the generalized hyperbolic stretch, which is all the rage now in YouTube videos, right? I just can't master it. And I'm quite happy with the simple thing, right? So I just use the histogram and I use the screen transfer function, which is basically these buttons I've been hitting on and off. It's this, that's what this is. So when I go ahead and click here, this radio active button, it goes ahead and gives you, what it thinks should be the stretch. And then all you do is drag that stretch over here. And I learned this on Masters of PixInsight, but everybody has videos on this now. And now if I turn that off and do a preview, it looks exactly the same. And as soon as I hit the square button apply, right, there it is. It's now stretched. So, I'm turning off the auto stretch function is meaningless. But if I turn it way up, you know, that's, you can see how much noise there's still, even though it has a lot of hours in it. But that's now, it is now stretched and able to work on. All right, so let's go back to our linear photo. So at this
One more-
point, oh, go ahead.
One last question. Give me your 30-second version of what is stretching.
I don't have a really succinct answer. I don't know if someone else wants to take a crack at it.
Stretching is pulling up your midtones, pulling down your black points. All of that data is there, but you have to pull up the midtones and the highlights or not the highlight. You got to pull down the black point, pull up your midtones, and pull up your white points.
Yeah. So,
Okay, thanks.
So just turn your preview on and do that again.
oh, okay, yeah. So if I drag the histogram over, it's brightening the whole picture, right? And that's what we did. Right.
You pull the black point back and get rid of some of that.
So let's do this. Let's do it without that screen stretch function. So we'll undo this. Oh, I got to go back here. Sorry. We'll undo this.
If you can go back to your lens.
Yeah. All right. So let's do it here. We're going to turn the preview on. It's black, right? So now I'm going to pull those midtones up.
Oh.
One of the things you usually, when you're doing this, you'll, like right now, it doesn't look very good, but now if he would apply it and then do it again, he can pull it. Same thing you did in Photoshop.
Yeah, right. So bring the black point down, bring the midtones up. See, you can do it all manually, right? And, you know, that looks like a nice start, right?
Well, to me, it looks like your button there is cheating.
My button?
Yeah, it's cheating. It's not right. That's too good. Yeah. I mean, that's all you got to do is pay $300 and get a button like that and save yourself a big hassle.
Yeah, well,
yeah, that's awesome.
Yeah,
I'm writing all this down.
Yeah, well, the problem is you just and what I can do, you know, for those of you who have it and want to play, I can create a workspace, a project file with all the icons, and you could, you know, use the icons I have. Of course, some of them you'd have to modify because they're made for my, you know, filters and whatnot, you know, back on the other screen.
Hi, Penny.
But all this stuff here, this could be used on any picture. You know, these are anyway, I should probably go through these a little bit. So I don't use, you know, I only use the histogram transform to stretch it initially. Sometimes I use a mask to mask things off. So I basically use one of those two.
So good.
I will hit noise exterminator again at the end. But the big ones are really this, you know, the HDR multi-scale transform. And that's really just what it does is it really kind of pulls the brightness out of the center. So if we put them side by side here. See, I've done a noise exterminator now. So see how clean this is looking? Still got some spots in here, but the HDR transformation here it's really highlighting, you know, the dark dust lanes that are in there.
Have you ever used the HDR filter on solar eclipses?
Well, I don't have any planetary setup really. So you'd have to ask maybe, I don't know, Walter, have you done that?
What was the question, Andy?
Using HDR filters
Oh yeah,
for
Greg,
solar
you've
eclipse?
done it. Yeah, Greg's done it.
Yeah, Greg, you can take this one. I do all my planetary processing in Redistax.
Yeah.
Yeah, I do too. So
Yeah.
what do you mean by HDR though?
Well, it'd be
High
whatever
dynamic
the
range?
equivalent. Yeah, yeah, yeah. High dynamic range. Some whatever the equivalent is in the other programs, right?
You know,
Not-
with solar, you only get a little bit of the corona in each exposure. And, you know, trying to pull that out without, you know, losing the fine stuff on the outside.
Well, with solar, I'm using a hydrogen alpha telescope, and I don't get the corona that I'm aware of. I've never been near an eclipse to image the sun while there's been an eclipse. So unfortunately, I don't think I have much experience with that.
We'll have a chance coming up.
That is correct.
All right. Back to the processing flow. The first thing I do after I remove the stars. So here is the stars only, and I use the star exterminator to do that. And what's left is star list, just this. So you still have all the noise, but all the stars are removed, but all the galaxies, or if it was a nebula, all the nebulosity would still be there, right? And again, it's a it's a one button thing. I don't even actually, I just drag it onto the picture and it does it, right? But this is noise exterminator on my first pass. I mean, it does a phenomenal job of cleaning up the noise. So I think is there one in? No, I don't think there is for Photoshop. Is there? I think there's a star exterminator for it, right?
There's a star reducer function that you have to learn how to do, but I don't know of a button that will remove the stars. Because this is another cheating thing. This would be awesome to remove the stars from my deep sky images. So when I process them, I don't have to worry about any artifacts on the stars.
Yeah. There is one.
I think Star Exterminator does make a Photoshop plugin.
Yeah, I'm pretty sure. It
Okay.
does. Yeah.
Let me write that down.
The gradient removal has a Photoshop
plugin.
Yeah, I'm pretty sure it does.
Oh, that's cool.
I'll be cheating by the weekend.
Yeah, and if not, the standalone version of Grexpert works just as well too. I used to use that all the time before the plugin came. All right, so I talked about the noise, I talked about the HDR, and then we get to what everybody's kind of familiar with is the curves, right? So if you look at now, yeah, I don't have much of a, I really didn't do a great job of processing this. That you should have a nice bump in here, kind of like, well, anyway. It normally would come up like this and this, but I just was hurrying through for the demo. But what you do is if you pick, here is kind of the black point and here is the midtones a little bit. So if I pull down, let's go to the preview. If I pull down on the black point and just pull up a little bit, so you have that nice S curve. Look at the difference there of what it can be. So, so what I ended up with after doing that was that, after playing around. So you could still see a little bit of that, what you were, somebody had brought up about the little blackness on the outside there. So the way I dealt with that was I added a mask. So I think I used a range mask. I just dragged and dropped now, but I would play with it a little more. And then when you mask things, so, you mask and then you invert the mask. You're protecting anything that's in the red, right? So obviously I took the time to cover. Do I have the mask? Yeah, I do. So that was my, where's this other mask? Range mask 1. Let's delete that. Yes. So when you apply the mask on there and then do the invert. Now, any sort of processing I do only is processing on the background. So that's the value of masks. And I know a lot of people online in their YouTube videos, they're really big on masks and they use them well. I try to avoid doing that as much as I can because I'm not very good at masks, but yeah.
This sure beats the old paper over the negative.
That's
what it is.
Yeah. All right, so let's put him back. So here's what it looked like. Oh, that's after. So I really didn't deal well with the black part like that was brought out. Like I said, I was in a hurry to just demo. But what is here is I have some bright spots that don't belong. So over here, so I did a little clone stamping, which is exactly the same thing in Photoshop, right? So, just did a little clone stamp and remove that. And then the last few, these last few steps here are really localized histogram equalization. They have all these great names for it, but they're really kind of, all it's doing is bringing out more detail in the dust lanes or in the darkness of nebula that you would have. So this won't take too long, but I can show you the before and after easily that way.
You have more power than Darth Vader.
Right, so here's before. So you can notice, let's go even closer. After. So it's not powerful, but it's subtle, right? And that's what I'm after, is subtle. So yeah, and then sharpening. Is it just a drag and drop too? It's got, settings I've put in there based on videos I watched. So it's a lot of time to do it initially, but once you have the icon saved, it's there forever, right? So let's just drop the sharpen on. And you can see the dust lanes are even more. More enhanced. And then I run the noise exterminator one more time. And this is kind of what I'm left with. Let me see. So normally too, I don't know if you're familiar with drizzling. So I normally drizzle my photos now, but that's why it takes all night to do that. So it's kind of the NASA thing that they used. I think, I don't know if did they start it with Hubble? But basically it takes your your picture, and it makes it double the size, and it makes the details less blocky, right, in the long run. So all this blockiness becomes a little more rounded, but I didn't do that on this one.
Andy, what camera are you using?
For this one, I think it was a 294 mm. So it's the same one that Mark's using now. I've since upgraded to the 2600.
Ooh, nice.
And let's see. So I sharpened, then I just add the stars back with, you probably have heard, if you're familiar with PixInsight at all, you've heard about pixel math, right? So we have our starless noise image, and we use the expression editor. And this stuff, you know, it takes a little while to learn. I'm not going to lie to you. But $T is the, you know, it's the target image. And so $T plus the stars image, and you get, boop, all your stars back. So, you know, as Greg inferred, you know, being able to process image without stars is really, really valuable, because the stars look perfect, right? They're round, and so yeah, so that's my final image as a result, and it still has the black around there. But anyway. So in the linear state, there's 1, 2, 3. Sometimes I use SCNR. It just removes the green curves, and sometimes I'll do some color saturation with it too. So, you know, but they have a color saturation tool, but I kind of like using the curves on it. And I click the saturation button. Let's do this. So, you know, usually with M106, you got more of the blues. So if you use the saturation, you start to see a little bit of the blue. Or you can just use the blue channel and boost it. Does it have a, yeah. Oh, okay. So here's the blue curve, right? So I put a point on there because I don't want the black point to change at all, but I want the midtones to change. So you see how it's now, it's a little bit bluer. So if I go all the way like that, right? So really with saturation, I used to boost it up like crazy, but I'm much more into, I just like the pictures to be what they are. So I only do saturation very sparingly. So my pictures don't end up looking like a lot of the really beautiful ones online, but that's just my preference, you know. And then if we add back to star, let's see, process stars, pixel math. Where are you, pixel math? I still have it. All right, so there you go. And you could do the saturation with the stars too. That's not always a bad thing, right? You can boost up the nice oranges and blue stars. Yeah, so that's essentially my process, and it's you know, I'm not counting the stacking part because, you know, I'm not physically have to be here, but for, you know, my 15-20 hour data, you know, it's going to take 8 to 12 hours to stack with my computer. A modern computer probably do it in 2 hours or less. So yeah, that's all I have. Any other questions?
I think we should start a GoFundMe for Andy to get him a modern computer.
I'll take it.
Got an old one. It's probably better than yours. So I'll give it to you.
Yeah, I mean, I've maxed out this thing as best I've added as much memory as I could put in. You can't upgrade the CPU. It's at the max for its motherboard, and yeah, whatever. it still works. So
Hey, Andy, have
Yeah.
you tried the new GPU processing library?
yeah, I have it running, but this processor is so old it's not even on the list of drop downs. So yeah, it maybe boosted it like maybe 5%.
Oh, okay.
Yeah.
Real quick, Andy, there's a fellow named Bill Blanchand. Have you ever
Yes.
heard of him?
Yeah.
He's
So
got some amazing scripts.
all right. So I don't have them here, but in my normal, because I wanted to keep this clean for as
Yeah.
clean as possible for you guys. So if I do Andy Min, because that's close them all anyway. We're throwing everything away. So
Yeah, I see some now.
that's my linear, and yeah, so here's all the masks that he has. And I don't use them very often. Maybe because I don't know how to use them very well, but anyway.
Yeah, I'd be happy to kind of show you the ones I use and why I use them.
All right, cool. All right, thanks everybody. We'll turn it over to Greg.
Before you quit, Andy.
Yeah.
When you're doing your one-shot color,
Yeah.
do you do much in the Hubble stuff with it?
Yeah, I'll play with it sometimes, but yeah, well, I normally don't mess with it too much anymore. I used to, but since I have the monochrome setup, I have the the real SHO, and then I play with things. I don't mind their being a little more artsy, because there's no green in space, right? So that's why they put the hydrogen into the green channel, because the sulfur's in the red channel anyway, or more in the red channel. So anyway, yeah. I hope that answers your question. Yeah, so some of the other scripts that I standard, yeah, I came up with my own based on other people's SHO pixel math thing, but if anyone's seen James Lamb, he has some good pixel math stuff I've used, but yeah, everything I've learned I've stolen.
I started to say, are you going to somewhere put those on a
yeah, I'll upload them to my Google Drive, and I'll put a link for the workspace. Both what I'll do is I'll put a link. I'll leave the demo workspace has all the files, so I'll do that one. It'll probably be a big download, but the workspace itself, or I should say the project itself, is not very large.
Well, thanks, Andy. I want to mention one thing about work process with something like this is that if you get the basic work process down, and then little by little branch out instead of trying to do too much at once, I find then I learn the program much better.
Right.
And it also helps me in steps realize what I need to do at the acquisition end to bring into the processing end. Right? Because you say, okay, I tried this and I had to do all this work on the processing end, but if I had done something a little bit different at the acquisition end, I wouldn't have to do so much.
Yeah, that's really the magic. Is the better the data, the easier it is to process. It's as simple as that.
So I've always gone, okay, what do I need to do at the process or the acquisition end to get what I want at the processing end? Because you could work for hours and hours at the processing end and never get there,
right?
Because you haven't done something either on calibration or acquisition somewhere in there. But that's why I'm saying it, just get the basic work process and then expand on it. Okay. So then, Andy, you're going to share or stop sharing, I guess, and then Greg can take over because I still have.
I already stopped sharing. Yeah.
All right. Thanks again.
Right, so I just have a simple one slide presentation to start out with. And basically going to be talking about how to stack and sharpen planetary images. And this is assuming that you've already acquired your videos. The preparation here up at the top is probably a separate talk in and of itself. And that includes things to know to keep videos properly sized for the object. And what I mean by that is you really do need to select a region of interest in your acquisition program when you're taking the images for the object. So with Jupiter, you need to have maybe a small little window that you're using to acquire the video of maybe 500 by 500 or 600 by 600. The camera that I was using to take the videos that we're going to be manipulating tonight was ASI 585, and the resolution was like 3400 by 2800. So it's like a huge resolution. And to try to stack those 30-second videos would have choked the computer. So you really do need to do something to make the video a lot smaller to be able to allow the program to do its stacking within like a few minutes as opposed to all evening. With the moon, I found that it was really okay to stack a full resolution image at 3400 by 2800. Those moon images that I sent out to the club were done in a relatively short amount of time with I think it was like a 300 frame video. It really didn't take much at all to stack those lunar images. But I'm going to go over stacking with AutoStacker and using the Planetary image preprocessor if it's needed. And I'll go over why that could be needed as opposed to like if you're, for whatever reason, you didn't do a region of interest when you took your image of Jupiter, for example, you're going to need to reduce the field of view of the videos from 3400 by 2800 down to something manageable like 450 by 450 resolution. Then I'm going to go into sharpening with Registacks, final adjustments with Photoshop, GIMP, Paint Shopper, any other program if needed. I'm not really going to cover that. This is just going to be the 2 points with stacking with AutoStacker and sharpening with Registacks. So I'm going to be sharing a couple times here. So this is the directory that I have that have the 2 different videos that I took on. It was December 20th. It was same day I got the 585. It would happen to be clear. And I knew that the weather was going to go downhill really quick. So I was rushing to get my AVX set up and to try to get anything out of Jupiter before the bad weather hit. So my options were F10, which is the video that the mouse is on right here with the little bitty dot, which is actually Jupiter. And the bigger Jupiter on the right-hand side was at F25, which, as I mentioned at the last club meeting, that may be too large of a magnification for the pixel size of my cameras. And at that point, if that's really true, no matter what you do with any processing, you're still going to get a fuzzy image. So as it turns out, the evening I was taking these images, I took the image of Jupiter probably 45 minutes after I set everything up because I was rushed for time, basically. And I think the images were a little bit fuzzy and not really focused as well as they could be after we do the processing. And the lunar images that I took probably an hour and a half later that I sent to the club, which were fairly clear, that was after my system got acclimated to temperature. So in any event, here are the 2 videos that we're going to be looking at. we're going to whoops.
Hey, Greg, I have a quick question.
Yeah, go ahead.
Did you record in AVI or SCR format?
AVI, and Walter has told me that he records in SCR, and that's supposed to be a raw format. Part of the 20 hours of videos that I watched was Christopher Go talking about that.
Yeah.
And he said he takes everything in 8-bit AVI and he's never noticed a difference. And you can't really argue with his results.
Yeah.
So I got very bad results when I did 8-bit raw with my Skyrus 132C. So all of these were taken in RGB 24 for what it's worth. So here, this is auto stackered. Wait a minute, I can't click on this for some reason. Let me stop the share. Let me try again. Right, so I've got auto stacker here. I don't know why this is locked up. Okay.
Zoom closed everything down.
Stand by. I think I understand what happened here. Okay, so do you see this screen that popped up, or no, you just see the, so do you see the screen that I'm moving around here with the red and black?
Yeah, it looks good.
Okay, so you can see that it's all black and Jupiter is nowhere to be found. So there's Jupiter right there, right? Can you see that fuzzy Jupiter?
No.
No. Okay.
No.
So how about that?
There you go.
Okay.
Yes.
So once you open the video with Auto Stacker, you get this screen that shows that it's 2400 by 2000. And this is like a huge resolution for this little bitty planet. So what you do is you go here with the width and you knock that down to like 424, and then you do the same thing. So if you didn't do a region of interest, you can still get your video down to a reasonable size by restricting the size that is going to be stacked here. The problem is once you do this, it's going to take about 5 minutes to process this image, and we don't really have 5 minutes to sit around and talk about stuff while this thing is working. So what I did is I used the Planetary image preprocessor and essentially did the same thing with this video. But what I wanted to show is a way to get a video that has a huge resolution and restrict it down to 400 by 300, I guess is really what it's saying here that this is. So is there any questions about that?
That's really handy, though. I didn't realize you could do that.
Yeah. Okay. So let me share again to, I think I've got pip running here. Yeah. Okay. So here's pip. So you guys see pip, right? And so here you click on add image files. And so this is the image, 49 seconds you see here with the F10 image. What I'm going to demonstrate tonight is the 30-second video over here. It was the F25 image, which should be oversampled, as there was a small discussion about during the meeting on Monday. So once you select the image, are you seeing the pip output frame over in the upper left over here?
Yes.
This thing that I'm moving around?
Oh,
no.
No.
Uh-oh, it says it's paused. Okay, so in any event, for processing options, well, first, under source files, you want to select Planetary because it's a planet that you're going to be manipulating. If you have a bunch of files, like you want to combine 5 minutes worth of 30-second videos, you could add all the files right here and then click on join mode down here, and that will create a huge AVI file with all of the frames from all of the AVIs that you've included here. So under processing options, you want to make sure that you have planetary objects selected up here for stabilization, and you want to make sure that cropping is enabled right here. And this will create, it will take that huge video that was 3400 by 2800 and create a cropped video right around Jupiter of 448 by 448. And then the quality options you can select here, and you could do your quality estimation. So here you can keep like a certain percentage of frames if you want to do your quality estimation at this point rather than through AutoStacker. You can do it here as well. You can also do it both ways. You could also select enable quality weighting, which I'm not really sure what it is, but I think it's supposed to help. But for now, we are just going to create a video with the same number of frames as the original video, only it's going to be cropped 448 by 448. So you go over here on do processing, you hit start processing. Turns out it takes the same 5 minutes to do this as PIP would have taken, or as AutoStacker would have taken when you reduce the image like that. So either way, you have to pay the piper with a 5-minute processing time here with this highly advanced computer that Andy does not have.
Yeah, I was going to say, you have a good computer too.
Okay, so let's go back to AutoStacker. So what I'm going to do is I'm going to go to open this video that has already been created with PIP. Did you see this image right here with looks like a huge Jupiter in a small window?
No, we're not seeing that.
No, not seeing.
Okay. Right here. You see that?
Yes.
Yeah. Right. So this is what PIP created. This is the AVI that PIP created with the previous function that I showed using the 448 by 448 cropped image that I selected in the output options. So this is the 448 by 448, and over here, let's go back to this guy, and then here we're going to analyze that video. And first thing it does is analyze. I'm not really sure exactly what it's analyzing, but I think you really need to do it. Christopher Goes said a lot of times he doesn't even analyze. So we're going to go ahead and analyze. I've already checked this out. It doesn't take 5 minutes. It takes just a few seconds.
Christopher Go probably has equipment that's unbelievable.
Well, he's got a 14-inch SCT, which is cheating again. Anyway, don't want to get on that anymore.
Atmosphere too. He has excellent seeing conditions.
Right. So after you've stacked your image with AutoStacker, this is whether you stack the PIP image or you reduce the frame of the original video within AutoStacker, as I showed at the first step before I went to PIP. You can do it either way. But the bottom line here is once you do the analyze, you have to stack it. So here you can see down here there's a drizzle option for 1.5 times drizzle. So this will increase the size just a little bit. And I got to admit, it wasn't until recently that someone mentioned it. It may have been Walter mentioned what drizzle actually was, that I realized why my Revolution Imager images from like 5 years ago were magically a lot bigger than what I thought the Revolution Imager was capable of. It's because I was stacking with an auto stacker and selecting drizzle 1.5. So there is an option within auto stacker, which F11 sends to stack 2, and there's a setup here where you can set to send the stack. So after you stacked your image here, it would automatically send that output to either a TIFF file. It creates a TIFF file, but it will automatically send that TIFF file to Registax. So if you're not running Registax, you can run Registax and manually go find the TIFF file that's created. But in this case, AutoStacker will automatically send the output to Registax. So if you have Registax running while you're doing the stack, it will automatically pop up in Registax, and that's what I hope to demonstrate here tonight. So now the next step is to go to this window here, and this is where you're setting the alignment points. And there is a little bit, I don't even know if it's controversy, but it's the number of alignment points that you really need for the stacking here. So if you go and select 25, you can see that that's a gazillion and a half alignment points. It's 600 alignment points. And for a while, I was actually using that because my computer could handle it in about a couple minutes. But then after watching these videos, what they suggested, what Christopher Go suggested, is you just have enough so that the boxes cover the perimeter of the planet like this. And there's really no need to use a gazillion and a half alignment points when 33 will do. So that's
Can you go over how you just selected that again?
Oh,
It looked like you selected 100, but
I did. I'm not sure. I think it's the density somehow. It's this could be. To be honest,
it's the size. The hover size of the alignment point, so that's why the boxes are bigger.
Oh, so it's pixels maybe.
Yeah,
could be 100 pixels, 200 pixels. Yeah. Okay. So the 200 pixels is not happening. Oh, that was clear. Sorry. 200 pixels, place on grid. Yeah. Okay. So by the way, as I mentioned at the meeting, when you're doing your preparation to take an image of Jupiter, for example, the standard is you want to have the same number of pixels as you have millimeters for your aperture. So if you have a 200 aperture telescope, you want to have 200 pixels for Jupiter. So what that means is the guy with the 14-inch telescope is going to get a much bigger image of Jupiter, and you're going to get a much better detail and all that resolution because he can tolerate a larger number of pixels with the same camera that I'm using. I can only tolerate like 200 pixels apparently, while a guy with a 14-inch telescope could probably, well, I've never calculated the number of pixels he can get, but I'm certain it's more than 200. So it's not a fair fight, as it were, but you have to keep all this stuff in mind. So in any event, we are, so here, I already have a f/25, which I believe is more magnification than the pixel size of my camera will allow. The 5 times rule, which is kind of big now, says that you want to have a focal length that's 5 times the pixel size. So if you have a 2.9 micron pixel on your camera, 5 times that is like f15, f14 and a half or something like that. So for me to do this with a f25 video is kind of like pushing it a little bit. But
Greg, to make you feel a bit better, there's now a push against the 5, and they're saying 7 is fine.
Right, that's still f20 on my system. So f25 is still pushing it. So
hey, real quick, the other thing I was going to ask you to do, since you were doing the alignment points, why do you need the alignment points? If you go up to the frames at the top and scroll through, you'll see the planet kind of jumping all around. That's why you need to align it.
Okay. Yeah, I didn't think the planet was really jumping all around with this video. I've got other videos where it was jumping around, but it wasn't. But I understand.
Minor atmosphere makes them kind of wobble a bit.
It may only be
Okay.
like 25 pixels, you know.
Yeah, right. I mean,
Yeah.
sometimes it actually goes out the frame, but I was just curious. how
I
you
think
just-
it matters in the ability to get the finest detail you can on Jupiter. And out of all the planets and the moon that I've imaged, for me personally, Jupiter is the greatest challenge because it has specific detail that is very difficult to get out. Walter got that detail out, and he's telling me all this stuff to do that I hadn't been doing until I saw his great image of Jupiter from like a month or two ago. And then I started getting on the bandwagon of Walter and doing everything that he's doing. So the only thing I haven't committed to is collimating my telescope every time I set it up. That just, I can't do it. But I may need to do it. So I'm
You need
reminded.
to collimate like every 30 minutes, Greg.
Yeah, I know. That's another thing. Okay, so under stacking options here, you can see that in the green says the frame percentage to stack. You know, I could have done this is like the quality estimation from PIP. So you could either do it in PIP, you could do the number of frames to use to stack in AutoStacker, and I really didn't know what number to use. I figure that since I'm a glass half empty kind of person, I should select 15 here. And then what I saw in one of these Christopher Go videos is he said that the percentage of frames to stack is basically an estimation of what you think you're seeing is. So he was stacking images where he is, and he used 70 because he thinks he has a 70% stable sky. So if you have a bad sky, you want to use 30. If you have an okay average sky, I guess you use 50. But anyway, that's how the recommendation from Christopher Go was as far as what percentage of frames to stack. It's all based on seeing, which I didn't even consider anything rational like that.
Yeah.
Okay, so down here for drizzle, because I'm already pushing it with F25, I left the drizzle off because I don't want to make a bad thing even bigger. So now the only thing to do is click on stack, and what I'm going to do is you can see that it's going pretty quick. And if I can find Registacks, oh, here it is. Okay, so now we're on Registacks, and when the thing has stacked and everything is completed, there's going to be a window that's going to pop up here, and then we're going to go to town on the wavelets is the plan.
Switch your screen. We're still looking at
PIP. Yeah.
we're still looking at PIP.
Thought I did. Oh. Okay, so here you
Thank
see
you.
this. Yeah, that's Registacks saying that it's sent the stack to Registacks. I'm going to click yes, and sharing a stop. This is great. Stand by.
Great. If you take the default, you just share your whole screen.
All right, so there is the image that we just. So that's the image that was stacked from AutoStacker. It's actually not too bad.
No.
I thought so. And I must say that the spectacular image that Christopher Go gets and even Walter gets looks a little bit like this. So it's just amazing what Registacks will bring out with the wavelet sharpening when this is what even the excellent images sort of look like. So what I have found is you have some adjustments here for initial layer. So if you leave the initial layer at 1, and so these layer adjustments is the size of the detail that's being adjusted. 1 is the smallest, 6 is the greatest size. The other thing that you want to keep in mind here is the denoise option here, because as it turns out, another benefit I got from watching all these videos is when I was um, adjusting the wavelet layers, I would get like pixelation on my image right here, and I didn't know what to do. I thought it was a bad image. Well, you can easily take care of that with the denoise feature here in Registax. And Christopher Go would say you could either do it here in Registax or you can do it in Photoshop. And what I have found is with my images, they're so bad that I have to like do it right here. When I adjust a wavelet and you get little droplets and noise, it's that denoise from that wavelet that I use to get rid of that noise. So if I were to adjust everything and then go to Photoshop to take care of the noise, I think I wouldn't get the result that I'm looking for, I guess is the best way to put it. So here, the initial layer is 1, and this is like the extreme amount of adjustment that the wavelets will adjust with Registax. Here, step increment seems like an even more radical increase in the adjustments from the wavelets. So I'll show you what I mean by that. So here, I happen to know that the second wavelet adjustment here will make kind of the biggest adjustment here. So you can see that that didn't do much to my resulting image, but if you can see on the screen here, it did kind of pixelate things a little bit. And if I increase the layer increment to 2, you can see that made a huge difference, right?
Yeah.
It just popped. So if you go to 3, you're getting pretty crazy. If you go to 5, 6, 7, so it just makes the amount of adjustment even more extreme by adjusting these initial layers. It could be that you're doing these layers down here now that I think of it. But adjusting this layer, maybe I found something new here with the layer adjustment, and the step increment is what I thought I was doing with the layer. So in any event, this is getting pretty good, but you can see that this is getting kind of pixelated here. And then 1 was another one that was adjusting a little bit. But before I do anything with 1, let me hit the denoise here. And you can see that after 3 increments of the denoise, it kind of got rid of a lot of that speckled business that was going on there. And then, yeah, so you can adjust these other layers a little bit, and it's kind of bringing out more detail down at the bottom. If I had a great image, this probably would have really popped. But in any event, I do believe that that is a lot better than that. So you can see what effect the wavelets can have. So there is an available scheme here that's part of Registax that I didn't start using until I saw Christopher Go use it. And what I have here is I created some presets for the wavelets, and the F25 here is what I ended up going with. So we're gonna, whoops, excuse me. So this was a final adjustment that I created with the different wavelets and their denoise options earlier this morning.
So Greg, I have a comment about the available schemes. So let's say you're taking image after image of Jupiter, like let's say every 5 minutes to make a movie.
Yeah.
And if you get your first one, your first image where you want it, then save that wavelet pattern in available schemes. And then each time you do it, you're saving all kind of time for each successive image.
Right. And
and again, you can save that for the next time you do Jupiter. Sometimes it works out that it saves a lot of time experimenting around that night.
Right. What Christopher Go was doing is he would have maybe 24 videos of Jupiter, for example, and he would load them one by one in auto stackered and use the same settings time after time and send the stack to Registacks, and then he would use the same wavelet scheme to get the same sharpening on the same resulting images, and he would save all the TIFFs.
Yep.
And then he would load all those into WinJupos. And I have since found the setting in SharpCap, which is what I've used to capture these images so far. There's a setting that makes the file names compatible with WinJupos, and what that does is the file name contains information about what the UTC time is for the midpoint of the video. So in that way, you could just load these files very simply into WinJupos to do the derotation.
Mm-hmm.
And yeah, the same thing with Fire Capture, which I haven't really used yet. So one thing I do want to point out, so do you see the artifact over to the right of the limb here on Jupiter?
Yeah.
The little bitty thing. So that is a thing that I had been masking out in the past because I kept getting this artifact, and I found out from these videos it's called the onion ring artifact. So people with planetary images do masks just like people with deep sky images to get rid of bad stuff. So what I found is the whole reason why you get the onion ring is because the gain was not set high enough as you were acquiring the image.
Oh, interesting.
So what the target gain apparently is for Jupiter is around 300. So I haven't been able to try all this yet, but next time it's clear with my new camera and everything, I'm ready to go, and I won't have a huge 3400 by 2800 video to deal with. So those videos that I took, the 30-second video was 30 frames a second, which is like 900 frames, 1500 frames, whatever the time was. And that's at, roughly 30 frames per second. So had I have basically been educated on what I was supposed to do, and I would have done a region of interest that is like 500 by 500 rather than 3400 by 2800, that resulting region of interest would have generated videos that were capable of 150 frames per second. So I would have gotten 5,000 frames or higher rather than the 900 frames that I acquired. And this is in the same 30-second time frame. Now, what I have found is when these programs take those 160 frames per second and it creates a video that's still 30 frames per second. So you end up with like a huge video that I think is much longer than the 30 seconds I think I'm going to be getting. The file size is going to be much smaller. It's just a much better thing to do a region of interest if your mount and the tracking will support it. My previous mount and tracking would not have supported that, as it turns out. But now that I've got the AVX, it's a huge mistake to do planetary imaging without region of interest.
Yeah.
So actually, these videos of Jupiter that I took on December 20th, the results were so bad that I was going to delete them, but this is probably the best I've been able to do with any of those videos. It's not as good as the video behind me, which this video behind me was taken the day after I got the AVX. I took my Skyris out and I had great tracking and great seeing. Everything was acclimated. And I got this. So now I'm looking at my backdrop there compared to what I'm showing you here with my new camera. And I'm like, boy, I got a turkey of a camera. But I think the seeing conditions, and I didn't I wasn't acclimated. I wasn't doing a region of interest. There was a lot of things I was doing that was going against me here on this this most recent picture of Jupiter. So I think that's basically about it for everything I wanted to talk about. So if anyone has any questions.
Yeah, Greg, could you reset all of the wavelets to 0 and the initial level to 0? Or it's at 1, okay. So this is just an FYI. What I used to do to start off with is I used to do a C shape on the wavelets. So Greg, if you could pull the number 1 over to about there, and then the next one about 2/3 of the way, and then the next one just a little bit.
Yeah, that's I used to do this too, by the way.
Yeah, well, I just wanted to show the okay, that right, and then bring the other 5 and 6 out, and then do all.
Yeah, so the thing that got me on wavelet layer number 2 is Christopher Go would actually show his Registack screen when he's done with his like Hubble quality images, and it's basically wavelet number 2 all the way over to the edge, wavelet number 1 maybe over to the edge, and the rest of them are nothing. And in order to get the fine little details of the wisps of the mutating liquid surface of Jupiter, the fine little intricate details, I don't think you want to do the big big amount of details on 6, 5, and 4.
I don't even use
think.
those, by the way. When I do mine, I'm up on 1, 2, and 3.
Yeah.
Playing around with the denoising and the sharpening there.
And then over to functions on where click on gamma, way to the right. Over to the right, way over to the right on their function.
Oh, yeah. Okay. Took me a while to see it.
The right side of the
No,
screen.
down on, go to your, now all the way to the right, over where it says functions. Up.
Oh, the Zoom window is covering it.
Oh,
okay.
Okay. Yeah. So okay. So
Okay, click on gamma.
Gamma. Okay.
It's another tool. So now you can play around with that on that curve in real time and get the planet to look all kinds of good stuff.
Did you do an RGB align on this, by the way?
Yeah, so that's part of the scheme here, unfortunately. Yeah. So
I
don't know.
Come through in schemes, I don't think. So if you click, I'll just try clicking on it, see if it changes it. Not the align, auto balance. There you go. Yeah, it doesn't resizing, rotating, and the RGB align and balance don't follow through on the schemes. At least I haven't found a way to do that.
All right.
Yeah, I learned it just the same way as you did. Made all these mistakes, and it's like, wait a minute, I didn't know it could do that.
Yeah. So yeah, if nothing else, I'm learning quite a bit, and like I keep talking about, Walter really helped me, so I really appreciate. I appreciate his patience, actually. Yeah, same with you, Andy. You don't want to leave you out either.
Yeah, so. No, not for this
planet.
Yeah, I don't know.
By the way, there's another Registax like thing, but it actually does everything called astrosurface.
Yeah.
Play around with that.
Yeah,
it's something entirely different, kind of, but it actually works very well.
Is that the one that's supposed to take the wavelet part out of Registax and make it its own thing?
Yeah, it's got its own approach to it, and it's actually, to me, a little bit easier because it kind of takes a little bit of getting used to, but these are free, so you can play with them and see what you like. But I happen to like it a little bit better than Registax.
Okay.
So does this allow you to make an S-shaped histogram or just the gamma change?
Like curves, you mean?
Yeah,
Yeah,
the
you can do that in the
luminosity curve.
Masking. Oh, there's masking right there. Huh. Yeah, I don't see anything.
You said there's
You click
masking.
on histogram.
Oh, histogram.
Ah,
So we can do the S-shaped curve if we want to really mess with it.
Yeah, you could.
Yeah, that's another thing I haven't gotten into is as I'm acquiring the image, I'm supposed to have histograms up and supposed to be at like 40% or whatever. I guess I'll figure it out in the springtime if I can get a planet.
yeah, right.
But
About 2 more weeks to get Jupiter.
yeah.
Well, thanks, Greg.
Okay.
Really
Thanks
fantastic.
a lot, Greg.
And Andy, thank you. And so now maybe what we could do is brainstorm how often do you want to do the meetings? I mean, the 2 hours tonight was pretty good, I think. How often do you want to do the meetings now? And what kind of subjects do you want to cover the next couple times? And when do you want to have the next meeting?
Once a month sound good?
Sure.
Yeah.
Sounds good to me.
And for
We could make it on the third Wednesday. That's what today is. Okay.
And I know for a subject, when not to use Unity gain.
Oh, yeah.
Gain and offset on all these ZWO cameras and that. I'm very confused on all that stuff.
You, hey, Mark, I'm willing to try to take a crack at that because I spent about 3 months trying to figure that out. And I think I did. So put me down for that.
All right. So the gain and offset. So Brian will do that. Then we talk about calibration frames. That would be another one to talk about.
can we do something with solar eclipse photography before April?
Yeah, that's a good idea.
All right.
Yeah.
So we have February 21st is the next third Wednesday. And then March 22nd because it's or March 20th because it's leap year. So that'll be the next couple. You know, probably March 20th, you could do the eclipse imaging, right? And maybe we can get a couple guest speakers on that who have done this many times, like Herman and Mark Christensen, as example. So maybe on February 21st, we could do the gain and offset stuff for Brian and then calibration frames. I could do something on that if you want.
Sounds good.
Okay. That sounds great. So I appreciate everybody participating in the meeting tonight. This is a great turnout. I think in the last year or so, our membership has increased and the interest in imaging across the hobby has increased. And so this is a great way to share the information and be specific about it. And as well, if you want to give a presentation at the regular meeting, feel free to do so for that too.
Later
Hey,
on
Mark.
down the line, I could do one on Nina if folks are interested in that.
Okay.
I would be, yeah.
Yeah. Yeah, also me. I've been using APT and I've thought about switching to Nina.
Okay,
I don't know what that is, so we'll have to.
Yeah, it's just an acquisition program. It's open source.
Okay.
What's really great about it is people can write plugins and there are about 25 plugins that people have written for it. It's all free, so and it's really nice. It does everything you need to do to have a complete automated setup.
Okay, and then like I said, I recorded this today, so I'll get that downloaded and then put on the group's IO. Any other suggestions for the meeting?
I'd just like to say thanks, Mark, for facilitating this. It's good.
Yeah, I think it's
Yeah,
important that we continue this because you can only do so much at the regular meeting, right? Because we have the regular subject matter and all this other stuff. But here we can pick out these subjects and get down into great detail with it. So yeah, this is great.
Hey, everybody have a good night.
All right, so what I will do is I will set up the next two meetings, the February 21 and March 20th, and send that notice out. And then reminders of that as well. Okay.
Hey, great.
All right. Thanks again.
Thanks, guys.
Thanks,
Thanks,
everyone.
everyone.
Nice cat. Nice cat. Thanks.
So here's a funny thing. So today is my grandson's 5th birthday. Or 7th. What am I saying? 5th, 7th birthday. And so the last year or so, he's been getting into Star Wars more than dinosaurs. And so Jeopardy's on today. And January 17th birthdays. And one of them, the answer was James Earl Jones. And one of the things is, Luke, I'm not your father. So I recorded it and then texted over to him. And so now he knows he has the same birthday as Darth Vader. All right. Well, thanks, Greg, again.
Don't forget to send him a Darth Vader card.
Yeah. We're going to see him Saturday. He's going to have his kid's birthday at the Birdo Center. The other thing is that he's into the Bulls now. So.
Oh, okay.
Gonna have a good time there. All right, everybody. Thanks again.
Thanks, Mark. Good evening, guys. Thanks a lot.